Hello everyone and welcome back. In this video we're going to learn about graph traversal, and the very first method or algorithm we're going to learn is going to be the depth first. So you can watch my videos about traversal of a tree and the depth first, so it's very similar to that. That we're going to go from one node to the furthest node possible from that node. That's exactly what happens in the tree. And it's a very similar concept in the graph, although there are some differences that I'm going to explain as I show the DFS or the depth first traversal with the graph G1 that you see here. So on the right side you see almost a pseudocode for the DFS. I wrote two methods. One of them is the DFS, which is a recursive function. It's called itself. The other one, the depth first search, the whole three words, actually prepares the settings for calling the DFS. So at first we're marking all the nodes to be unvisited, and the reason that we need a marker or flag for each node, because it might be the case that the graph contains some cycles, and to avoid repeating and visiting the nodes that are in the loop, we need to use these like the flags for each node to in order to prevent that issue that we have. So at first we're setting all the nodes to be unvisited, and then as we continue, we're gonna just call a DFS for every vertex or node in the graph G that we have. So the DFS method, as you see, it receives a vertex or a node as a parameter, the type T here. If you have watched my other videos, it just stands for a generic, means that the type of the nodes or vertices will be specified later. So we're going to visit we can be just maybe printing the information, or maybe just setting a flag. In this case also it includes the setting the flag. So here when we see visit also includes setting the node set v as visited as well. And then for every adjacent node or vertex of the node v, then we're going to call the DFS one more time. So with this graph G1, I'm going to explain how the depth first traversal of a graph works. At first all of them are visited and unvisited. Okay, so now we're starting from a node in the graph. So the graph we can just choose anyone, or it can be maybe based on the some keys that we're going to start. But let's just here in this graph that we have, let's just start with the graph with the node or the vertex B, although it doesn't matter. Maybe we have some rules to decide the one, but here we're going to just choose the node B. So here, as you see, B is unvisited, and we're going to call the DFS for the node B, and we're going to visit the node V and set it as visited. So I'm going to just put a check mark here in order to show that we have visited node B. Then for every adjacent node of node B which is not visited yet, which are the nodes A and D. So these are the adjacent of the node B. If they're not visited, which is the case for now, we're gonna just call the DFS for that one. Here again we can choose either A or like the D. Let's choose A. So we're gonna call, and I'm gonna write the like the way that we call this one. So we call the DFS of B, which says visit B. Then here we call the DFS of like the A, DFS of A. So DFS of A will visit the node A. So here we're going to write visit A. So let me just put a check mark here that's saying that we visit the node A. After that, we're gonna, for every adjacent node of A which is not visited, so for sure the nodes that are adjacent of A are B and K. However, we have already visited node B, so the node that we're going to visit next is going to be the node K. So that means that we're going to call the DFS of the node K. So which we'll call the visit or visit function. So we're going to visit K, In other words, we're going to check k as visited here. Then we're going to call the DFS for every adjacent of node k, which is not visited. For sure, the only node that is not visited here is the node D, because A is visited already. So we're going to call the DFS of node D. So this will call the visit function. So we're going to visit function visit the node D. You can put a check mark here, and then now the node D has like the three neighbors, B, K, and C. However, nodes B and K already are visited, so the next one gonna be the node C. So we're gonna call the DFS of node C, which means that we're gonna call the visit function of C, and then here's the check mark. So we have visited all the nodes, and then C has only one like the neighbor, which is D, and it's already visited, so there's no more need to call the DFS function. So we're going to go back to where we actually call, and here there's one, and then DFS of D, which was the neighbor of K. So here K will try to call the DFS of the A or B, because again both of them are visited, so we're not calling DFS again, and then we're going to go back to where we call the DFS of A. Here it's not trying to call the DFS of B, but again because you have already visited B, so we're not going to call that, and then it's going to go up DFS of B. So this time it tries to call the DFS of D, but we have already called the DFS of D, so there is no need, and that's going to end the depth first traversal of the tree. So as you see, the flow of the way that we just traversed or just visited. So we started with the node B, and then so that's the very first one, and then we visited node A, and then we go to the the K, and then from K to D, and from D to C. So as you see here, we started from B, and then we went to the very the furthest node of the tree, which was C. So although the node D was the immediate neighbor of D, immediate neighbor of B, and we might expect maybe to visit the node D at the very beginning, but that wasn't the case. So we started with B, we went to the A, and then the K, and then D, and then C. So D was at the the fourth node that we visited, rather than to be either the second or the third one node to visit. So that's the very simple recursive version of the depth first traversal of a graph G. For sure, if you're having a direct graph, we should be careful. When we talk about the JSON, it means that there should be an edge which goes from the any node, call v subscript 1 to the node v subscript 2, and if there's not, so maybe we need to choose another node that there is an edge between these two, and not just choosing any random or just choosing any node just because there isn't a connection. So there should be connection, like the one that's going out. So for example, if we have B to the A, then we need to call that adjacent like the vertex. So in other videos, I also explained the depth first traversal of a graph, so you can watch also that video. Also, you can watch the videos about the trees and other videos that I posted about the graph.